In this tutorial, I'll be talking about temperature salinity variation in Adelaide coastal waters. Okay, so you get the task to work out variations in environmental conditions. Okay, temperature and salinity are two key properties determining the environmental conditions in a region. Okay, so what is the temperature in winter? Okay, we're talking about Adelaide metropolitan water here in this sketch. You can see that red rectangle, and above my head is sort of the depth distribution and the extent of this area. Fairly shallow water, between 10 and 40 meters. And so what's the temperature in winter? Have you ever gone swimming in winter time? That you should try that. Jump into the water and work out what is the temperature. Not with a wetsuit, indeed. Do it without a wetsuit. What's the temperature? Go in summer. What's the temperature? Salinity is a little bit more tricky. You need to taste the salinity, and you have to have a very fine taste, because salinity doesn't change much, but it changes over the seasons of the year. So in this assignment, you're given temperature and salinity data collected during different months of the year within this red zone. Okay, different depths, can be in the north, can be in the south. Okay, so you get characteristic temperature and salinity data. So now it's about the interpretation of the data. So first thing, let's have a look at the data. You plot the data. You worked out how to plot data using Excel, and you put some labels on it. Okay, so temperature, this is a temperature salinity diagram. Okay, so I turn on the pointer here. The vertical axis, the y-axis, is temperature in degrees Celsius, and you can see it goes from 10 degrees to 28 degrees. And the x-axis is salinity, and salinity in grams per kilogram. Okay, so it varies between 36 and 38.5 grams per kilogram. It's a very subtle difference, but anyway. So now here you can see different months of measurements. You see during February you have the highest temperatures. Okay, 25 degrees, 22 degrees, something here. There's quite some variation in here, but that depends on whether you measure in shallow water and deep water in the northern parts or the southern parts of this zone that I just showed you. Okay. In contrast, you have in May, June, it's down here, have temperatures of 15 degrees Celsius, and the salinity is increased. Okay, it's at 38. And then the coldest period is that of August and September, where you have temperatures of down to 12 degrees Celsius. Okay, so fairly cold. So now it's about the interpretation. What happens? You know what happens in the Gulf, creating this seasonal cycle of temperature and salinity. And moreover, what's good about this? You've done that, say, for 1 year. Well, this seasonal cycle will repeat for year after year after year after year. This seasonal cycle will be the same. Okay, there will be some slight differences, but overall it will be the same. You can now look at it, and you can predict for the next February what will be the temperature range and salinity. Okay, and you know all about the timing of temperatures and salinity values now once you have collected 1 year's of data. But there's more hidden in it. So, for example, what causes the temperature variation? Okay, temperature going up into summer, and then dropping, going low into winter. Yeah. Winter. Okay, and spring, and then going back up again. And that question is probably easy to answer. And we come back to that. You know, you might already know the answer. However, salinity changes. Okay, you can see that the salinity goes up and then drops, and goes up and drops. What causes that? Okay,